Good afternoon. We are starting a new chapter, chapter 3, logic. You want to start probably a new page in your notebook, and it might be a good idea to call it chapter 3. And the title is a one-word title, logic. I got a couple little notes on this page also. If you look, it says logic is from the Greek word logos. And logos in Greek means word. So there's a definite connection between logic and words. Which seems kind of strange for a math class. But I guess what that's trying to tell us is, how can you be logical without words? And I don't know, any of you know anything about Bible study software? But that's actually the logo the logo for the Logos software. Logos is Bible study software. And the reason that's a good choice is because it's studying the Word. And so, it's kind of a neat connection there. Okay, so we got a little intro. Seems odd. We're going to be dealing with words, but how else can we express ourselves, really? And to get you thinking a little bit about this, we're in a liberal arts college here, and I'm sure you've heard of that term, liberal arts. You probably even had to take what? Were you in that group that still took a class on some kind of a liberal arts class, like your the one that's for freshmen? It's called College 101. Didn't you guys talk about the liberal arts in there?
For one of the classes.
Yeah. Well, anyway, this is a liberal arts college, and originally there were 7 liberal arts. I can't fit them all on the screen. I'll show you the other one. But here they are. And you just notice how many of them are mathematical and how many deal with words. Grammar. There it is, right away. Logic. Rhetoric, which is like speech. Arithmetic. Music. Geometry. And I just didn't have room for astronomy. I mean, look at how many of those original 7 really were mathematical. Astronomy is very heavily math. Geometry, arithmetic, that's 3. And then logic, is what I'm telling you today, is really also mathematical. It's 4 out of the 7 are related to mathematics. So anyway, we're going to delve into that one called logic. And, I guess you could call logic kind of a tool to help you with your other learning. Because if you get logic, all the information you read will now be clearer to you. So it's kind of like an equipping type thing. And so, you're not getting a full course in logic, but still, it should be helpful to you in not just mathematics. It kind of helps clarify things. And it allows you to solve some kinds of problems. And of course, our course is all about solving problems, so that's where we're headed. 2 guys that are going to come up. You've already heard of the guy on the right. Remember when I showed you De Morgan's laws? Well, that's Augustus De Morgan on the right. We're going to be using his laws again in this chapter. And logic, the type of logic that, by the way, without logic, you wouldn't have any computers or any devices of that type. And the kind of logic that computers use is called Boolean Logic, named after George Boole. And so those 2 guys were some of the early thinkers. And you notice, now that may look like a long time ago, but actually that's pretty late in the math game. Mathematics has been done, well, since way before Christ. And some pretty hefty stuff. Euclid's geometry was written 300 years before Christ. And that's the same geometry we still learn. So I mean, math's been around for a long time. This stuff, this logic, came quite late in the game, if you will. More recent. Okay, then our first lesson of chapter 3 is called statements. And I'll explain some of those weird sentences up there in a few minutes. Don't worry about them. Already one person here was trying to clue me in on the fact, somewhere in my text, oh yeah, right of the first one. What I say today is, you know, I've been doing this. No, actually, I have that up there for a reason, but we'll get to that. So anyway, now officially, maybe this is the time to bring it up right now. A statement in logic terms is any sentence that is either definitely true or definitely false. Either one is fine. So that top sentence up there is a statement. It is very obviously a false statement. Therefore, it is a statement because it's true or false. See, we got the wrong school there. But oh, that's all right. It's false. The course identifier for this course is, that's correct in this. Is that right? I got my schools mixed up. Yeah. Okay, that's good. And then the next one has a problem, and that's why I put a line through it. A question can't really be termed true or false. So as soon as you have a question, nothing against it, and if you want to write questions, go right ahead, just that they're not going to be called statements. So just, you should write yourself, so what's a statement? You should put that term in your notes someplace. Statement. And however you highlight in your notes, if you underline them, you might as well do that right away. So based on what I've told you, what would you write? What is a statement? Yeah, a sentence that's true or false. And the emphasis there is it's got to be one of those two. You can't have like, here's one. What do you think about this? It is beautiful outside today. Is that definitely true or false? Well, there are some problems there. The problem is, what in the world does beautiful mean? It could mean a lot of different things to a lot of different people, okay? To an Eskimo, this might be unbelievably beautiful. To somebody from one of the southern states, you might think, this is insane. Okay, and so the problem is, a word like beautiful is way too fuzzy, right? And it's so many different things to different people. Whereas the top one there can be no argument. It is not February 44th. And so there's no, well, that all depends how you look at it. It's just purely false. So you get the problem. So we don't want to, so what do we want to do? We want to stay away from, I don't mean to be too critical here, but it is beautiful today is way too wishy-washy. It's not defined clearly at all. So statements need to be defined clearly, and either clearly false or clearly true.
Yes. So pretty much facts.
That's a pretty good way to say it. Yeah. I don't know if you'd call that top one a fact. I guess either true. If you call that a false fact, then I would agree with what your use of the word is. What do we call a false thing? I don't know. Just false. Okay, it's garbage. But it's clearly defined. It's not like, well, like if I made a comment like, I don't know what the, I guess I've already done it with a beautiful day, but this is a great class. The problem is, what's great? Again, it just hasn't been defined. Now, if I defined it and said, well, it has the following characteristics, then we could check it out. But Okay, you get the idea. Um, 44 plus 44 equals 88. That certainly is true. And that's really a sentence, isn't it? It's even got a verb in it, equals. 44 plus 44 equals 44 is also a statement, but clearly a false one. So the thing about equations is, you can't be wishy-washy. You're either true or false with an equation, and so they're gonna pass pretty easily. Now, what does that mean? I'm writing off all other questions and all things like that? No, it just means that we're not going to study all those other things in this particular chapter. And you're going to find that we can come up with some really useful rules for dealing with statements. Okay, now a little tie-in between the previous chapter and this chapter. You notice that little table at the top. You should already recognize this upside-down horseshoe. Remember that as, well, you remember it as intersection. And then this one was union. Well, the words we're going to be using in connection, I mean, there's nothing wrong. I should write that off to the side because I'm not trying to, ignore that. I'll tell you what, I'm going to take that whole, if I can get this thing up and running. I'm going to grab this whole part and move it over a little bit. And then we'll write in here that this is intersection. That's what we called it in the previous chapter. And this, of course, is union. And you notice this is new. Well, partly. I think I told you about it in the last chapter, but for intersection, the English word and really means the same thing. If you're in that street and that street at the same time, you're really standing in the intersection. And union is really a pretty common usage, the English word or, and those are both conjunctions. Now, in the sets chapter, these are the symbols we used. In this chapter, these are the symbols we will use for the same thing. Notice they're very similar. The only difference is instead of rounded, they're pointed. That was kind of cool. So even though you might say, well, dummies, they could have used the same symbol for both. That's true, they could have. But I'm kind of glad because I want you to be familiar with both. You'll see both in scientific literature. So I want you to be aware of both. So this means exactly what that meant. It's just that in logic, we don't use the rounded, we use the pointy. And the union, instead of rounded, pointy again. Here we have a little bit of a switch. When we had the complement, now we're going to put this little wavy, almost like a wavy negative sign. It still means not, just like it did here, right? Didn't a complement before mean not in set A? Well, little negation sign A really means the same thing. But it's a little unique, because this one came after the letter, and this one comes before. Okay. Something that that actually will take a lot of your attention in this chapter is called finding negations. Negations. And in fact, a number of questions, probably a bunch of questions on the test, I'm going to tell you already on the first day, are going to deal with negations. Well, the first thing we're going to teach you is that when you have a statement with the word all in it, you know, like if I said, all of you were on time to class today. Okay, what's the negation of that? Now, you're tempted to say, none of you were. Kind of go overboard, but that's not true. What you want to think of in a negation is, what does it take to make my first statement a lie? Okay, so if I make that statement again, all of you were on time for class today. Now, what does it take for that to be a not true statement? just, all you need is one, right? So, do you see what I mean by all of you were on time for class? The negation of that is at least one of you was not. You follow? So in other words, you don't go overboard and say all of you were on time, none of you were on time. No, that's like the opposite. I don't disagree with you. It's just that for a negation, you want to give me just enough to kind of make my statement into a lie. Okay? Now, let's come up with a sum statement. Like, I don't know. Some of you have food and drink with you. Okay? Now, what would it take for that to be a lie? Some of you, of course, you know what the word some means. What? And by the way, in logic, when we say S-O-M-E, we mean at least one. Okay? So even if there was only one person, I could say that. So what does it take for that to be a lie? If I say some of you have food or drink with you. The only thing that would make that a lie is nobody does. So here's your first two little lessons on negations. When you want to negate an all statement, you have to kind of turn it into at least one is not. And when you want to negate a some statement, you have to turn it into a none. Clarification?
No, I get it. I was just wondering, if the type is some, what if we all did? So would that negate the some type?
No. Thank you for asking that, because that's a good question. So let me go back and say that again. Some of you have food or drink with you. Now, would that be a lie if all of you did? No, it only shows that I made an understatement, right? I mean, if all of you had food with you right now, and I said, some of you have food with you, in logic, that's an accurate statement. It's maybe not as accurate as it could be, but it's accurate. So, a little different. I see where you're coming from now, because I could do a lot better than that. I could say, all of you have food today, and it would be more accurate. That's
I was just trying to ask what that would be if you said all of you have food or drink with you. That is a false
If
statement.
I said all of you have food or drink with you, that is false. Because all it takes is one person not.
So it's just a false statement.
That's just plain flat out false. Correct. So, yeah, that's another good clarification. Does everybody see that? From a logic point of view, if I say all of you are eating food right now, that is false. And the reason is because I can point to at least one person in the room that is not eating. That's all it takes. And so whenever you make an all claim, you really better make sure you got your buttons in order before you make a statement like that. You know, like when you say to your mom, yeah, well, I took all the garbage out. For that to be true, you better have taken all of it out, because even if you left, that can thing or something, and you didn't take the recyclables out, you didn't tell the truth, okay, from the logic point of view. Yes?
Now, can those be done in reverse, just making it a none statement or a some not?
Yeah, thank you for bringing that up. So let's do it the opposite way. So what if I said to you, let's start on the right side. What if I said, there's at least one person in this room that does not have food? Well, what would be the negation of that? If I said there's at least one person in here that doesn't have food with them. The only thing that would make that a lie is if all of you had food, right? Yeah, so these are reversible. Or how about this one? What if I said nobody has food in here today? What would make that a lie? All it takes is one person who does, right? Okay. You'll get used to that, but that's the way we're going to be looking at, and see, that's the mathematical way of it. So in other words, if we say some, what we really mean is at least one. I know some of you, I don't disagree with you. If you think about it, the word SOME kind of implies plural, doesn't it? but in logic we mean at least one. There's one or more. Okay, cool. Good discussion, because we're going to want to keep clarifying that. Okay. So, if you remember, I told you De Morgan's laws, the same laws that we had in the previous chapter, are going to be in this chapter. Okay. Above the dotted line, these should look familiar. Hopefully you look at those and go, oh yeah, we had those in the previous chapter. Well, here's De Morgan's laws in this chapter. Now you'll notice there's a couple differences. Notice instead of using the apostrophe for the complement, now I'm using that little wavy, kind of like a minus sign. And instead of it being at the end, it's at the beginning. That's a little different. And in place of this rounded thing, now we have this. And in place of this rounded thing, now we have this. But otherwise, that should look awfully familiar. And that's because it's the same two laws. And guess what? They're just as true in logic as they were in sense. Okay, I'll tell you what. I'm gonna stick my neck out, even though we're probably not quite ready for this. I'm gonna try it anyway. What I'm gonna do is make up an A and B statement, and then we're gonna negate it. Okay, and then we're gonna see how it compares to this. So let's do. Let's say I gotta make up something now. Just a minute. This is what I'm not so good at. Okay, here we go. Let's say statement A is, I came to class on time today, and statement B is, I taught you a little bit of logic. Okay? So, I came to class on time today, and B, I taught you a little bit of logic. So there's the A and B. Now, what would it take? I'm going to negate that. Let's say it's not true that I came to class on time today and I taught you a little bit of logic. What would it take to make me a liar? Think about that. I came to class on time today and I taught you a little bit of logic. What would it take for me to have not made an accurate statement? Either or. So in other words, either I didn't come to class on time today, or I came to class on time, but maybe I didn't teach you any logic. That's exactly right. And so, you notice, look at, here it is. What's the negation of I came to class on time today and I taught you a little bit of logic? I didn't come to class on time today, or I didn't teach you some logic. Yep, De Morgan's law. And you just did a good job of interpreting it. Yes?
If it will be false, negation.
What's that?
If they-
Yeah.
Like
Thank you. This, another excellent statement. This or is what we call the inclusive or. And it's either that one, or both. Yeah, good observation. There is an or that's not inclusive. We call it the exclusive or. I'll give you an example. Maybe you're watching a football game, and somebody you're watching the game with has to answer the phone or something, has to leave the TV set, and they were just kicking a field goal when he left. So he comes back, and he knows that they either made the field goal or they did not. There is no way both could have occurred. You don't get 3 points and not get 3 points. It's all, of course, based on the ruling of the officials, right? So there's a case where you can't have both. But, for example, what about this one? So that's an exclusive one. But then there's this one. You can get that scholarship if you have a GPA of 3.25, or if you have, I don't know, 30 on your ACT test. Now, what do you think they would do with the guy that did both? He'd get it. So there's a case where it isn't. So you're right. That's an excellent question. There's sometimes we include, and sometimes we don't. But this one, I can guarantee you, always includes. Good question. You guys are sharp. So, main point of this slide, the good old De Morgan's laws are alive and kicking, and they act exactly the same way in logic. And I guess I repeated that. Didn't need to do it twice. We've already looked at these. Now, I would just like you to evaluate this crazy thing. Okay? Now, there's a problem here. Do you sense what it is? I mean, if it's telling you the truth and it really is false, then it must be true. But if it's true, then it's false. You see how it turns back on itself? That's weird. Yes.
So does that mean that it's not a statement anymore?
That is exactly correct. And in fact, we have a special name for it. It's called a paradox. If you, by the way, you can also find a paradox if you walk down this hall back here, because there's a pair of docs. There's Doc Schultz and there's Doc Frisky. Yeah, thank you for laughing. All right, that's EC. Way to go. Anyway, but the paradox in our chapter is when a statement disagrees with itself. I don't know how else to say it like this. This is not a statement, as Matt said, but you should know that this is a paradox. And I misled you by telling you a pair of dots. It's a single word, paradox. And now, okay, now this one's a little bit different. So this is not a statement, this is a paradox. Now this time I have two sentences up here. Okay? Now each one is okay. Wouldn't you agree? If I just take the top sentence, does that disagree with itself? No. But put them together and we got a problem. Because look at what the top one says. The top one says, you know that sentence below me? That's true. And then I read the sentence below, and it says, you know that one above? It's false. And then I go back and look at the top and go, holy cow, if that's false, then the statement below is not true. And if the statement below is not true, oh, yeah, you got all the, these two statements disagree with each other. That's a little different. So at least, yeah, I used to say, yeah, it's not good when you get in an argument with yourself, and it's really bad when you lose the argument. Don't try to make sense of that. But, you know, if you disagree with yourself, we got a real problem. We probably need some special attention from maybe some people with some white coats on or something. I don't know. But these statements individually, they can be legitimate, but when you put them together, they don't work together. And this has got a name too. These are statements. And when these two statements don't agree with each other, we call that, you probably know. I'm sure you've heard this word. Let's see if you can come up with it. I'll give you a hint. These two statements blank each other. Contradict. Yeah, it starts with C-O-N. So this is a contradiction. And this won't come up until later in the chapter, but I thought I'd bring it up because, you know, like this is the one where, you know, Mom comes home, she finds the cookies are gone, the cookie batch she just made today, they're all gone out of the cookie jar, and all that's left is crumbs. And she calls in the two suspects, the two kids, and one kid says, I didn't eat any. And the other kid says, Ralph ate them all. And those two statements contradict, you know, and we see this all the time in the courtroom. you know, they don't agree, and we gotta, obviously, somebody's not telling the truth, and, okay. All right, but the big lesson today is this slide. What's a statement and what is not? So let's just quick review that, and then I'll let you get going early for this first lesson. Remember, what's a statement? A statement is a sentence that is either for sure true or for sure false. And hence the slide, even garbage statements like the first one are statements because it's very clearly false. Well, the only thing we can't take are questions and things like, oh, she's cute. You know, and if you ask somebody if you agree with that, well, that all depends on your definition of cute, okay? And again, if we ask an Eskimo, cute could be a lot different, you know? Oh, didn't you see that really neat nose she has, you know? Remember, they kiss by rubbing noses. But anyway, it could be a whole different deal, right? Okay. So, a lot of the assignment questions are of that type. Let's maybe just take a peek. Yeah, and I don't, I think it's, your assignment's going to be the odds from 1 to 55. And I believe that's posted on the website. So when you get to the assignment on page 114, the first 8 say, tell me, is it a statement or not? You know, like number 1, I love this one. Circles are dreamy. Yeah. Just what you were thinking, right? No, yeah, of course, the question is that true or false? And what in the world is dreaming, you know? We could each have our own definition of dreaming. Now, you know, just take a look at number 2. Lemons and oranges are citrus fruits. Now, you might go, well, it sounds correct, but I'm not sure. So what should I do? Well, isn't it something we could check out? The point is, we could look it up to make sure, couldn't we? Mm-hmm. And so that's got to be a statement because we can tell, we'd be able to check if it's true or false. Okay? But circles are dreamy. I don't care what you look it up under. How are you going to get a definitive word on that? You're not. Okay, you get, so that's 1 through 8. Lesson, part B. Conjunction, disjunction, and negation. Okay, I see some terms I could have used. You know, did I have that on that slide? Mm-hmm. I didn't say it, but it was on there. It's on that slide. Did I have it on this one? Yeah. I didn't talk about the word and being a conjunction. And I know in English, I think we call or a conjunction too, don't we? I think and or are both conjunctions in English. But in logic, we call the or a disjunction. And conjunction. Conjunction, disjunction. So when you see in number 9 going on, it says, hey, what is it? Conjunction, disjunction, negation. And they give you letters. So they say, this is April, and income tax returns must be filed. This is April. You can use A to stand for that. And income tax returns must be filed. We're going to call that statement F. How can you write, this is April, and income tax returns must be filed? A, F. You just pull out this symbol. So you don't have to write out the words. They want you to use them. Yeah. This chapter, I got to warn you. You just gave me this idea. I got to warn you, in this chapter, I'm going to be doing a lot of hand signals. Okay? And honestly, if people came by the door when I'm doing this, they probably would send the white coat people for me. Okay? Because I'm going to be doing things like this and stuff like that. You'll see. It's coming. All right. Because I think it'll help you with your memory work. And, what's that? She's starting to do some of them already. Yeah, well, actually, we'll be doing a little... We'll be doing a bunch of that, okay? Yeah. So be forewarned. Let you go. See you on Friday.